Hello everyone and welcome back to the Python Machine Learning Beginner course. Today we are going to talk about a very interesting topic, that is naive Bayes. I made some interesting slides to give you the basic understanding about naive Bayes classification. I'm super excited about this. So without further ado, let's get started. Well, in order to understand naive Bayes classification, first we have to understand the Bayes theorem. Here we can see a range. Let's say in a factory, there are two machines, machine 1 and machine 2. Let's say machine 1 produce some wrenches every day and machine 2 also produce some wrenches. So in order to track which wrench come from which machine, we tagged them like this, M1 and M2. So by seeing this tag, we can easily detect which wrench came from which machine. Okay, after the end of the day, we got so many wrenches. And out of all these wrenches, we got some defective wrenches as well. So the question is, by using Bayes theorem, we have to find out what's the probability of a wrench from machine 2 is defective. Let's try to solve this problem. Okay, this is our Bayes theorem, that is probability of A given B is equal to probability of B given A into probability of A divided by probability of B. Okay, now it sounds a bit weird, but don't worry, I'll explain all this notation step by step. Now let's get back to the example first. Let's say we know some information about those wrenches. Let's say machine 1 produce 30 wrenches per hour and machine 2 produce 20 wrenches per hour. And out of all produced parts, we can see that 1% are defective. And out of the all defective parts, 50% came from machine 1 and 50% came from machine 2. Because remember, all those wrenches are actually given a tag. That's why at the end of the day, we can able to identify which defective wrenches come from which machine. So our question is, what is the probability that a part produced by machine 2 is defective? Now let's try to write this down, all this information in a probabilistic manner. If we consider first two information here, that means machine 1 produce 30 wrenches per hour and machine 2 produce 20 wrenches per hour. That means these two machines produce 50 wrenches per hour. So probability of a wrench from machine 1 is equal to 30 by 50 is equal to 0.6, and probability of a wrench come from machine 2 is equal to 20 by 50, which means 0.4. Now we know all of these wrenches 1% are defective. So we can write it down in this way. That is, probability of defect is equal to 1%. And out of all defective parts, 50% came from machine 1 and 50% came from machine 2. So we can write it down in this way. That is, probability of a wrench is defect which came from machine 1 is equal to 50%, and probability of a wrench is defect which come from machine 2 is equal to 50%. And we can write down the question, probability of a wrench is defect came from machine 2. So the question is about what is the probability that a part produced by machine 2 is defective. So we don't need actually any information about machine 1. So we can eliminate these two information and left off those information which we will need in the future. So if we write down this like Bayes theorem we saw earlier, then the equation will look something like this. And if we put all the value that we calculated earlier and put this into this equation, then we will get 0.0125. That means 1.25%. So probability of a wrench is defect which come from machine 2 is equal to 1.25%. So we have already got a basic understanding about Bayes theorem. Now let's talk about naive Bayes classifier. Naive Bayes classifier is actually use Bayes theorem in order to classify dataset. So this is our Bayes theorem we saw previously. Let's say now we have a dataset like this, where in x-axis we have age and y-axis we have salary information about 30 employees. And the employees, which actually indicates by red cross, go to work by walking, and the employees which actually indicate the green cross go to work by driving. Now let's say there is a new data point which actually represent a employee's information, but we don't know whether this person go to office by walking or driving. By using naive Bayes classifier, we are going to figure it out whether this employee go to office by walking or driving. Let's find out. So this is our Bayes theorem. In order to solve this problem, we have to follow some steps. In step 1, first we are going to apply the Bayes theorem to the person who walks to office. Here probability of an employee walks to office is called the prior probability. So in order to solve this equation, first we are going to find out this value. Then this is called the marginal likelihood, that is Px. Here x represents the feature of that employee. We are going to calculate this second. Then this is called the likelihood, which is probability of a feature given the employee walks to office. And thirdly, we try to find out this value. And after find out those three values, we can calculate the posterior probability that represent the probability of a person walks into the office given the feature. Then in step 2, we will do the same for the person who drives to work. So similar to the previous example. Then in step 3, we are going to compare these two values that we calculated earlier. Probability of a person walks to office given the feature versus probability of a person drives to office given the features. Now we are going to calculate all of this step by step. So are you ready? Let's go ahead and calculate all these values together. So this is the step 1, where we are going to find out the probability of a person walks to office given the features. So first we are going to find out the prior probability. So this is our graph, and we are going to find out probability of a person walks. So this one is very easy. Here we have the information about 30 employees. So probability of a person who walks to office is equal to number of walkers divided by total observations. So that is 10 by 30 according to this example. So we completed the calculation of prior probability. Now let's find out the marginal likelihood, that is probability of x. So here first we remove the new data point. Now let's draw a circle around this. It's the input parameter. You have to give the input by yourself. Now if we consider this radius, those data points which actually inside this radius is actually considered the similar data point. So P of x is equal to number of similar observations divided by total observations. So we can write it down by P of x is equal to 4 by 30. Because you can see in the radius we have 4 data points and the total observation is 30. So we just calculated the marginal likelihood. Now let's calculate the likelihood. So we are going to again draw this circle. So probability of the feature given the person walks to office is equal to number of similar observations among those who walk divided by total number of walkers. So here we actually consider only the person who walks to office. So we don't need the information about the person who drives to office. So the number of similar observations among those who walk is equal to 3, and total number of walkers in this graph is equal to 10. So the probability of the feature given the employee walks to office is equal to 3 by 10. So we have already calculated the likelihood. Now if we put all this value into this equation, we can get the posterior probability, that is 0.75. That means 75%. So the probability of a person walks to office given the feature is equal to 75%. So step 1 is done. In step 2, we will do the same that we did in the first step, but this time we are going to consider the person who drives to office. So similarly, if we find out all the values that we did in the step 1 and put this value into this equation, then we get the posterior probability, that is probability of a person drives to office given the features is equal to 0.25, that means 25%. So step 2 is also done. In step 3, now we are going to compare the probability of a person walks to office given the features versus probability of a person drives to office given the features. So that is 75% versus 25%. So As we can see, 75% is greater than 25%. So we can say for that new data point, the probability of that employee walks to office is greater than the probability of that employee drives to office. So according to our calculation, now we can say that this new data points actually belongs to red category. That means this employee walks to office. So this is the way actually naive Bayes classification helps us to classify new data point based on the previous information. I hope now you understand how naive Bayes classifier works in an intuitive level. Now let's go ahead and get started by jumping to the Spider IDE to implement naive Bayes classification in a project. So without further ado, let's get started. Okay, now I'm here in Spider IDE. First, I'm going to copy all these lines of code from our logistic regression Python file and paste it in our naive Bayes Python file, because remember, in the previous few tutorials, we are actually working on different types of classification algorithm where we actually used social network ads.csv file. So here we are going to also use the social networks ads.csv file in order to implement our naive Bayes classifier. That's why I copied all these lines of code from our logistic regression Python file and paste it here. We just have to change our code just in this section where we are going to feed our naive Bayes classifier to the training set. Now let's run these lines of code to import our libraries, then import our dataset and also split our dataset into training set and test set. And then we are going to do feature scaling. Now it's time to feed our naive Bayes classifier to the training set. Let's type from sklearn.naive Bayes import Gaussian NV. That means Gaussian naive Bayes. Then we are going to create a classifier by typing classifier is equal to Gaussian NB open and close parenthesis. And finally, we are going to feed our classifier in our training set. So let's type classifier.feed. In parentheses, we pass xtrain and ytrain. Okay, now let's run these lines of code here. Now it's time to predict our test set results. Let's run this line and go to the variable explorer and open our ytest and ypred value. So here in the left side you can see this is our ytest value, that is the actual value of our purchased column, and in the right side we have ypred that actually predicted by our naive Bayes classifier. Now it's time to create a confusion matrix in order to find out the accuracy of our naive Bayes classifier. So let's run these two lines of code here and open up the CM variable. So here you can see our naive Bayes classifier correctly predicted 65 plus 25, that means 90 observations, and it incorrectly predicted 7 plus 3, that means 10 observations. So we can say that our naive Bayes classifier achieved 90% accuracy. In the next lecture, we are going to talk about decision tree classification. So for all that goodness, I look forward to see you in the next lecture. Until then, enjoy machine learning.